In Calculus 1, you learn the integration of trigonometric function. Your understanding of the integration of trigo function is very helpful to perform the integration of hyperbolic function. Now, let's look back at the integration formula for trigonometric function. From here, we can see that we have 6 formulas under integration of trigonometric function. The first one is integration of cos x dx equals to sin x plus c. The second one is integration of sin x dx equals to negative cos x plus c. The third one is integration of sec square x dx. It is equals to tangent x plus c. The fourth one is integration of sec x tangent x dx. The answer is sec x plus c. Okay, the fifth one is integration of cosec x cot x dx. The answer is negative cosec x plus c. And the last one is integration of cosec squared x dx. The answer is negative cot x plus c. Now, what about the formula for integration of hyperbolic function? If you look at the left and right columns, both are very similar. They are different is in hyperbolic function, all of which need to be placed h behind it. And the first 3 functions are positive when integrated, while the last 3 functions are negative when integrated. You do not need to memorize this formula because it will be provided in the appendix in the final exam. From here, you can see all 6 integration of hyperbolic functions are given in the appendix. So, you do not need to memorize. But, under the integration of trigonometric function, not all formulas are given. So, you can modify the formula of hyperbolic function to get the formula for integration of trigonometric function. But you need to be careful with the positive and negative signs. Okay, now we look at example 1 in page 29 in chapter 2. Evaluate integration of 2 sinh for x cos for x dx. Here are the complete solution. To integrate 2 sinh for x cos for x dx, we can use u substitution. We can choose u equals to cos for x and then we differentiate. So after we differentiate, we have du over dx equals to 4 sinh for x. And then we can write the x as a subject. So we have dx equals to du over 4 sinh for x. And after that, we can replace dx by du over 4 sinh for x. Okay, here. And then we can simplify the same term. Okay, we have sinh for x and then sinh for x from denominator. So we can simplify. And we can simplify constant 2 and constant over 4 here. Okay. So after we simplify, we have half. We move out half. Okay, we have half integration of cos for x du. Okay. Until here, we still cannot integrate because we have cos for x in terms of variable x and at the back we have du. So we still cannot integrate. So what should we do is we need to replace cos 4x by u. Okay. And then now we have all in terms of u and du. So from here we can integrate with respect to u. We just use power rule to integrate because no more hyperbolic function here. Okay. So when we integrate, we still have constant half outside here. Okay. Then we integrate u with respect to u using power rule. So we have u squared over 2 plus c. Okay. And after that, we need to replace u in terms of cos 4x. And then we simplify. So we have 1 over 4. We replace u by cos 4x. So we have cos squared 4x plus c. Okay, you got it? And then for the same question, we also can choose u equals to sin 4x. Just now, we choose u equals to cos 4x. Okay, now we also can use u equals to sin 4x. Why? Because if we choose u equals to cos 4x, we can simplify sin 4x here. And if we choose u equals to sin 4x, we can simplify cos 4x here. Okay? But the final answer looks different. But actually, there are equivalent in terms of hyperbolic identity. Okay? When we choose u equals to cos 4x, the final answer in terms of cos 4x. And when we choose u equals to sin 4x, the final answer in terms of sin 4x. And another method, okay, we can use double angle identity. The given question is integration of 2 sin 4x cos x dx. Okay, so from page 3 in chapter 2, we can refer formula sin 2a equals to 2 sin a cos a. And if we replace a equals to 4x here, we can write sin 8x equals to 2 sin 4x cos 4x. Okay. So now, if we have integration of 2 sin 4x cos 4x dx, we can replace by sin 8x. So from here, okay, we can straightforward refer from appendix in final exam paper. Formula number 8. We have integration of sin ax dx equals to 1 over a cos ax plus c, where a equals to constant. Okay. When we use this formula, the final answer is 1 over 8 because our a is 8 cos 8x plus c. The answer looks different, but actually it is equivalent in terms of 3 hyperbolic identities. Okay? Got it? Now, we continue with example 2, page 30, chapter 2 in your handout. Evaluate integration of cosec 1 over x cot 1 over x squared dx. Okay. To integrate this question, we can use u substitution. We choose u equals to 1 over x because if we have cosec u cot u, we can refer directly in appendix. Okay, in hyperbolic function. Okay. If we choose u equals to 1 over x, after that, we need to differentiate. Okay. When we differentiate 1 over x, first step, we need to change into the form of x to the power of negative 1. Okay. So, using power rule, after we differentiate, we have negative x to the power of negative 2. Then, we bring x to the power of negative 2 to denominator. So, we have negative 1 over x squared. We write in terms of positive exponent. Okay. Next, we write dx as a subject. We cross multiply. We multiply dx by negative 1. Okay. And then we multiply du by x squared. So we have negative dx equals to x squared du, or positive dx equals to negative x squared du here. Okay, after that, we replace u by 1 over x. Here, we replace u equals to 1 over x. Okay, and we replace dx by negative x squared du here. And after that, we can simplify x from denominator and x squared here. Here, we can simplify x squared from denominator and x squared from here. Okay. And after we simplify x squared, we can move out constant negative, and then we have integration of cosec u, cot u du, all in terms of variable u and du. So from here, we can integrate with respect to u, but this time we need to integrate using hyperbolic rule because we still have hyperbolic function here. So to integrate hyperbolic function here, we can refer from appendix that will given in your final exam paper. Okay, formula number 13. Okay, integrate cosec ax cot ax dx equals to negative 1 over a cosec ax plus c. So if we replace a by 1, so we have integration of cosec single x cot single x dx equals to negative 1 over 1 is negative 1. So negative cosec x plus c. Now we have integration of cosec u cot u du. So the final answer is we still have negative outside, and then when we integrate cosec u cot u du, we refer from this formula. Okay, so the answer is negative cosec u plus c. Okay, and after that we can multiply negative by negative. So we have positive cosec u plus c. And finally, we replace u equals to 1 over x. So the final answer is cosec 1 over x plus c. Okay, got it? Coming up next, still under integration of hyperbolic function, we will discuss example 4 in page 31, chapter 2 in your handout. Evaluate the definite integral tan x sec cube x dx. Okay, so stay tuned. Bye. Assalamualaikum.